Hi class, so this video is the Unit 2 free response review. If you are able to complete the following 10 questions and you feel very comfortable with them, then you are definitely going to be ready for that Unit 2 free response section for this upcoming exam. So let's go ahead and get started. So for this here, we've got to solve the following problem and graph the solutions, right? So we're going to follow these steps. We want to isolate the absolute value. So when we isolate it, we're going to have 2 absolute value of b minus 1 plus 2 equals 8. So to isolate this, I'm going to first want to subtract 2 from both sides. So I'm going to have 2 absolute value of b minus 1 equals 8 minus 2 is 6. I'll then want to divide both sides by 2. And so we'll get the absolute value of b minus 1 is equal to 3. And I'm going to go ahead and box this in yellow here because this is our isolated absolute value, and that's super important. And we're going to use this to solve our two cases, right? So that first case, okay, the absolute value of b minus 1 equals 3. For the first case, you just drop the absolute values. So b minus 1 equals 3, and you solve. So we'll add 1 to both sides, and I get b equals 3 plus 1 is 4. Okay? For the other case, for that second case, okay, I'm going to take the absolute value of b minus 1, set it equal to 3, and I need to apply the KISS method. So KISS it, right? So we're going to switch the signs here and here. Well, for these equal signs, nothing really switches, so we're just left the absolute value of b minus 1 stays equal, but now it is to negative 3. So we have to switch that sign. Okay, we drop the absolute values. We have b minus 1 equals negative 3. We add 1 to both sides, so I get b is equal to negative 3 plus 1 is negative 2. And these are our 2 points. So if I come here on a number line, what we can do is we're able to free range this. What we can do is we can say, well, let's set this to 0. We can create this however we'd like. And to do b is 4, well, we'll go 1, 2, 3, 4. And we'll put a point, and it's a closed point because it is equal. There's no inequality lines anywhere, no lines going to the left or right because it is just that point. b is 4, done. For negative 2, well, we come to negative 1, negative 2. We put our point, and that is it. So these are the steps for the first question. Okay, we went through every single step. We isolated, solved for this first case, applied the KISS method, we solved it, and graphed. Okay, so let's go ahead and move on to the next problem. For problem number 2 here, we're going to do the exact same thing. We want to isolate the inequality, the absolute value. So we'll say 2 absolute value of 3n minus 2 equals 16. We'll add 2 to both sides. So we get 2 absolute value of 3n is equal to 18. Divide both sides by 2. So I get the absolute value of 3n is equal to 9. And I'm going to box this because this is my isolated absolute value. So we're going to take that isolated absolute value and we're going to solve for the first case. So we're going to say the absolute value of 3n is equal to 9. Drop the absolute value, so we have 3n equals 9. Divide both sides by 3. So I get n equals 3. And this is our solution for the first case. Step 2 done. To get the second case, we'll set up the same isolated absolute value, that 3n equals 9. We're going to apply the KISS method. So we want to switch these two here. Well, we'll have the absolute value of 3n. Well, we can't switch an equal sign, but we can switch that positive 9 to a negative 9. Drop the absolute values, so we'll have 3n equals negative 9. Divide both sides by 3. And so we get n equals negative 3. All right, so let's go ahead and graph this. We'll put a nice 0 here in the middle. To get our first point at 3, we'll say 1, 2, 3. There's our first point. To get our second point, we'll say -1, -2, -3. And there's our second point. Okay. So we went through all the steps, and we graphed. Let's go ahead and move on to the next problem. So for this next problem here, we're going to do the same thing. We want to isolate it. So we'll say 2 absolute value of x plus 2 plus 1 equals 9. We'll subtract 1 from both sides. So we'll have 2 absolute value of x plus 2 equals 9 minus 1 is 8. Divide both sides by 2. So I get the absolute value of x plus 2 equals 4. We're going to go ahead and box this. This is our isolated absolute value. So when we solve for that first case, we're going to take that isolated absolute value, that x plus 2, set it equal to 4, drop the absolute values, and we solve. So x plus 2 equals 4, subtract 2 from both sides, we get that x equals 2. Cool. To get that second case, we take the isolated absolute value, x plus 2 equals 4. Okay, and we apply the KISS method, where we're going to switch the equals and that 4 if it's applicable. So we'll have the absolute value of x plus 2. Equal sign stays the same, but we're going to go from 4 to -4. We drop the absolute value, so we say x plus 2 equals -4. Subtract 2 from both sides. So we get x equals -4 minus 2 is -6. Okay. We can set this up a little differently. We can still put the 0, but we're going to shift it off. I'm going to put it over here, actually. And you can really put your 0 wherever you like. This is your graph. Feel free to do it however you like there. And then for that x equals 2, we're going to go 1, 2, put our point, and we're good. To get our second point at -6, we'll go -1, -2, -3, -4, -5, and -6. And we have our point here. All right, guys, so we went through this. We isolated the absolute value, got the first case, got the second case, and we graphed them. Okay, let's go ahead and move on to the next problem. So we need to isolate our absolute value. So we'll say the absolute value of b over 2 plus 4 is equal to 6. Subtract 4 from both sides. I get the absolute value of b over 2 is equal to 6 minus 4 is 2. And this is our isolated absolute value. Okay. And so let's go ahead and solve for that first case. So we're going to say the absolute value of b over 2 is equal to 2. We drop the absolute value, so we'll say b over 2 is equal to 2. Multiply both sides by 2. So I get b equals 2 times 2 is 4. To get that second case, okay, we set up the same thing, the absolute value of b over 2. This is our isolated absolute value. We need to apply the KISS method, where we switch. So we're going to say the absolute value of b over 2 is equal to, and now we're going to go from 2 to -2. And we apply the same thing, right? So we drop the absolute value, so we'll say b over 2 equals -2. Multiply both sides by 2. So we get b equals -2 times 2 is -4. Okay. Let's go ahead and put our 0 in the middle. To get our first point, we're going to go 1, 2, 3, 4. Put our point here. To get our second point, -1, -2, -3, -4. And we have our second point here. Okay. All right, so we got the first isolated absolute value. We got our first case, we got our second case, and we graphed. All right, so let's go ahead and go on to the next question. This is going to be the last one for equals. Okay, so the last function, we'll do inequalities after this. So we want to isolate our absolute value. So we're going to say the absolute value of 4p minus 4 equals 0. Okay, and so when we isolate it, we'll add 4 to both sides. So I get the absolute value of 4p is equal to 4. Let's go ahead and box this, as this is our isolated absolute value. Okay, and let's go ahead and solve this. So we're going to say the absolute value of 4p is equal to 4. Drop the absolute value, so we get 4p equals 4. Divide both sides by 4. So we get p equals 4 over 4 is 1. Okay, to get the second case, okay, we're going to say the same thing. 4p equals 4. We're going to apply the KISS method, where we switch the equals and switch that value 4. So we'll get the absolute value of 4p is equal to negative 4. So then we drop the absolute values. We'll say 4p is equal to negative 4. Divide both sides by 4. Simplifies out. We get p equals negative 4 over 4 is negative 1. So let's go ahead and graph it. We put our 0 in the middle. Our first point is at 1, close point. Our second point is at negative 1, close point. And that's it, guys, for solving for these absolute value equations, right, with the one variable. Okay. And so these are all with the equal sign. So now let's go ahead and move on to some inequalities. So with these inequalities, we follow the exact same steps, guys. We're not going to change any of the steps. The only thing that's going to be a little different is our symbols and how we graph this. Okay. So let's go ahead and work on the first one here. Okay, and we're going to do the same thing. We want to isolate the absolute value. So if I have 6, absolute value of 6 plus x is less than 18. Well, I want to divide both sides by, not 3, by 6. Divide both sides by 6. So those 6's simplify out. And we get the absolute value of 6 plus x is less than 18 over 6 is 3. So let's go ahead and box that, because this is important. And so for that first case, we're going to say the absolute value of 6 plus x is less than 3. We drop the absolute values. We say 6 plus x is less than 3. Subtract 6 from both sides. I get x is less than 3 minus 6 is negative 3. Okay. For the next case, for that second case, we're going to set up the absolute value of 6 plus x is less than 3. We apply that KISS method, where we switch the sign and switch the number, and this is going to affect the sign. So then we'll say the absolute value of 6 plus x is now greater than negative 3. We drop the absolute values. We say 6 plus x is greater than negative 3. Subtract 6 from both sides. I get x is greater than negative 3 minus 6 is negative 9. And those are our answers there. Okay. So we got negative numbers on both. So when we graph these guys, we want to just be very careful. So you don't really necessarily want to put a 0 on this when we're graphing. What we'll do here is let's go ahead and just put our first case. I'm going to put it right here. I'm going to say this is negative 3. And it's going to be an open circle. Remember, it's open because it is not equal to. It does not have that little bar on the bottom. And we're going to the left. So we're talking about all the numbers that are less than. Okay. For our other number, we have a negative 9. I'm just going to put it here at negative 9. It's not going to be, it doesn't need to be perfect on the spacing, but it does need to be in the right order. So negative 9 is smaller, so it does need to be on the left. It's going to be an open circle, and this is going to go to the right because we're talking about all the numbers greater than negative 9. And this is how we would graph this. Okay. Finish taking your notes on this, guys, and you can always rewatch this part, but we're actually going to do 4 more problems very similar to these. Okay, so let's go ahead and move on to the next one. So for this one here, let's go ahead and isolate the absolute value. So we'll say a plus 5 minus 4 is less than or equal to 7. So we'll add 4 to both sides. Simplifies out, we get the absolute value of a plus 5 is less than or equal to 7 plus 4 is 11. And we're going to box this. This is our isolated absolute value. And we're going to use this for our first case. So we'll say the absolute value of a plus 5 is less than or equal to 11. Drop the absolute values. We'll say a plus 5 is less than or equal to 11. Subtract 5 from both sides. I get a is less than or equal to 11 minus 5 is 6. And that's our first one. To get that second case, okay, we're going to say the absolute value of a plus 5. Remember, we're using that isolated absolute value, but then we need to apply the KISS method where we switch the sign and that value on the right. So to do that, we're going to say the absolute value of a plus 5 is now greater than or equal to negative 11. Drop the absolute values. We say a plus 5 is greater than or equal to negative 11. Subtract 5 from both sides. Simplifies out. I get a is greater than or equal to negative 16. Okay, so let's go ahead and graph these. To do that, guys, we can just put our 0 in the middle, no big deal. And we're just going to rough estimate these points. So let's go ahead and say that right here is 6. We'll just label this here as 6. It's going to be a solid point. Solid again because it is less than or equal to. And this is going to be going to the right. To get our other point, we'll just say that this is going to be at negative 16, close point. And this is going to be going to the right. And this will count as graphing your inequality. Again, feel free to watch this part of the video again if you have any issues, or send me a message and I will be more than happy to help you guys out with this. But let's go ahead and move on to problem number 8. Alright, so looking at problem number 8, we have the absolute value of x plus 6 plus 3 is less than 7. So to isolate this, we'll subtract 3 from both sides. So I get the absolute value of x plus 6 is less than 7 minus 3 is 4. And let's go ahead and box this, as this is our isolated absolute value. So for that first case, we're going to say the absolute value of x plus 6 is less than 4. Drop the absolute values. We'll say x plus 6 is less than 4. Subtract 6 from both sides. I get x is less than 4 minus 6 is negative 2. Cool. For that second case, we'll say the absolute value of x plus 6 is less than 4. Apply the KISS method, switching and switching. We'll say the absolute value of x plus 6 is now greater than negative 4. We drop the absolute values. X plus 6 is greater than negative 4. To solve this, we subtract 6 from both sides. So I get x is greater than negative 10. So when I graph this, we just want to make sure that we graph it in some type of order here. When we know that negative 2, we'll just say this is negative 2 here. We'll use an open circle because it does not include the equal then, and we're graphing this to the left. And then here at negative 10, we have an open circle and we're going to the right. Okay. We've got 2 more, so let's go ahead and do that now. Looking at number 9 here, guys, we have 10 absolute value of n plus 1 is greater than or equal to 90. Divide both sides by 10. So we have the absolute value of n plus 1 is greater than or equal to 9. Box this as it is our isolated absolute value. And our first case here will be the absolute value of n plus 1 is greater than or equal to 9. Drop the absolute values. N plus 1 is greater than or equal to 9. Subtract 1 from both sides. I get n is greater than or equal to 8. To get that second case, we're going to say the absolute value of n plus 1 is greater than or equal to 9. We need to apply the KISS method. Switch, switch. So we'll say the absolute value of n plus 1 is less than or equal to negative 9. So then when we solve this, we drop the absolute values. We'll say n plus 1 is less than or equal to negative 9. Subtract 1 from both sides. We get n is less than or equal to negative 10. These are our values here. So we'll put our 0 somewhere here in the middle. Not a big deal. Our first point will be at 8. So we'll say this value here at 8. We'll use a solid circle because it is an equal then. It's greater than or equal to 8. And this is going to be discussing all the values to the right. For our other value, we'll say over here is negative 10. We'll use a solid point. And this is all the values to the left. It's all the values that are less than or equal to negative 10. Okay. All right, and let's do one more together. Number 10, number 10, number 10. And I want you to pay close attention to number 10 because something's going to happen here. So when we have this, we're going to say the absolute value of negative 7x plus 6 is greater than or equal to 13 when we subtract 6 from both sides. So we get the absolute value of negative 7x is greater than or equal to 7. Let's go ahead and box that because that's important. That is our isolated absolute value. For our first case, okay, we're going to say the absolute value of negative 7x is greater than or equal to 7. Drop the absolute values, we get negative 7x is greater than or equal to 7. Divide both sides by negative 7. So that simplifies out, so we get x. 7 over negative 7 is negative 1. Now, something important is happening here. This sign is going to switch. And it switches because we divided by a negative number. So we're going to get this for this problem here. So x is less than or equal to negative 1. Again, because we divided by a negative number, our sign switches. Okay? Well, let's go ahead and work on the second case. So we set up the same equation. Absolute value of negative 7x is greater than or equal to 7. Apply the KISS method. So switch, switch. So we'll have the absolute value of negative 7x is less than or equal to negative 7. Okay, we drop the absolute value. We say negative 7x is less than or equal to negative 7. Divide both sides by negative 7. These simplify out. I get x. Negative 7 over negative 7 is a positive 1. Now, because we divided by a negative 7, which is a negative value, our sign flips again. So we have this here. So be careful, guys, when we're dividing or multiplying by negative numbers, not adding or subtracting, just multiplying or dividing by a negative number, your signs need to switch. So let's go ahead and graph these. Our first point says x is less than or equal to negative 1. So let's just put a 0 here. And at negative 1, we'll put a closed point because it's also equal. We're talking about all the numbers to the left because it's all the values that are less than negative 1. For the other value, we have x is greater than or equal to 1. So at 1, we have a closed point. We're talking about all the values greater than 1. All right, guys, so that concludes our work for the Unit 2 free response review. This is due in your notebook, so you're going to want to finish this up, and it does count as bonus points for your exam. Hopefully this video helps. If you have any questions, send me a message, and we'll see you on test day, guys. Bye-bye.